again, this is Mrs. Israel coming at you from Einstein High School. We're going to be working on Unit 1, Topic 3, Question 19 from the Algebra 1A exam review packet. Okay, number 19, solve the following exponential equations. Okay, we've done a few of these now. So hopefully we remember our first step is to check and make sure that we have like bases. Write it with me. First step. Like bases. All right, so looking at question A, we have 3 to the power of x plus 2 equals 3 to the power of 7. So the first thing I'm going to look at and see if I have a common base, and sure enough I do. These are both going to have a base of 3. Once I have a common base, I actually get to ignore them. So I'm going to rewrite this equation just as x plus 2 equals 7 and solve. That leaves us with a one-step equation. I need to get rid of that positive 2. I'm going to use the subtraction property of equality and subtract 2 from each side, and I get x is equal to 5. And that's it for part A. All right, part B. First step, let's check and see if we have common bases. So I see 25 to the power of x plus 1 equals 5 to the power of x minus 3. So I have two different bases, and what I'm going to look and see, is there one that they have in common? I'm going to start with a smaller one, base 5, and ask myself, is there a power of 5 that equals 25? Absolutely, yes, there is. 25 is equal to 5 squared. So I'm going to rewrite that as 5 squared. Don't forget the x plus 1, it didn't disappear. And I'm going to leave the other side as 5 to the power of x minus 3. All right, we have to use the power rule here. So I need to raise a power to a power. I have 5 to the power of 2 raised to the power of x plus 1, and the power rule tells us to multiply our exponents, so we end up with 5 to the power of 2 times x plus 1 equals 5 to the power of x minus 3. All right, from there, now that I have like bases, I can actually ignore them. So that's going to be 2 times x plus 1 equals x minus 3. Give myself a little more room over here. Copy that again. I need to use the distributive property. I'm going to multiply 2 times x and 2 times 1, which gives me 2x plus 2. And now I have an equation with variables on both sides. I'm going to get my variables to one side, my numbers to the other. So I have my variables and I have my constants or my numbers. Let's start with the variables. So I'm going to subtract x from both sides just because it's smaller. It makes it a little easier. I like to avoid negative numbers. That leaves me with 1x plus 2 equals 3. We can subtract 2 from both sides, use the subtraction property of equality, and I get x is equal to 1. And that's the solution to part B. Alright, finally we have part C. First step is like bases, and I can see that we do not have a shared base. We have 9 and 27. So we have to think, is there some factor, 2, 3, 4, 5, that when I raise it to powers is going to give me both 9 and 27. Think about it for a second. And hopefully you thought of 3 and you would be correct. So 9 is equal to 3 squared and 27 is equal to 3 to the third power. So these are both going to be rewritten with a base of 3. So let's do that. So instead of 9, I'm going to write 3 squared. And instead of 27, I'm going to write 3 to the third power. Don't forget those variables and numbers that were already there. You can't leave those behind. All right, we're going to apply the power rule and multiply our powers. So that's going to be 3 to the power of 2 times x plus 2 equals 3 to the power of 3 times x. Now that our bases are the same, I'm going to cancel them out and rewrite my equation. I need to apply the distributive property. It's going to be 2x plus 4 equals 3x. My goal is to get my variables to one side, my numbers to the other. Since that 3x is by itself, I'm going to move the 2x over to join it. So let's subtract 2x from both sides. And I am left with 4 is equal to x. That's it. And we are done with question 19.